My name is Dr. Marissa May. In this lesson, we're going to be looking at exponent rules, all about when we multiply, when we divide, when we're raising a power to a power. Let's jump right in. So when we are multiplying monomials with like bases, or you might think of these with like variables, then we simply add the exponents. So let's take a look at a few examples so we can kind of clarify this. When we look at number 1 here, I want to go ahead and multiply the numbers in front. So 3 times 4 here would give me 12. But when I look at the end of the second times the end of the fourth, let me show you what really happens. End of the second means to multiply n times n. End of the fourth means to multiply n times itself 4 times. So if you multiply these together, you're actually multiplying 6 n's times itself. So we would say that is n to the 6. Now the shortcut to that is I can just add those exponents. 2 plus 4 would give me the 6 here. Now let's look at example number 2 here, and we'll throw in an extra variable. Again, multiply those numbers in front. Negative 3 times 5 gives me negative 15. Then work with the a's first. So remember, a to the second means a times another a would give you a to the third. Then let's do the b's. So b to the third means b times b times b, and b to the fourth means b times itself 4 times. So how many b's are there that are being multiplied together? You got it, that's 7. Okay, now when we do problem number 3, I'm going to actually throw us back to our distributive property, and we're going to use our exponent rules that we're using right now. So when we distribute p to the second times p to the third, I'm going to do p to the second, which means p times the p there, which will give me p to the third. Then I'm going to do q to the third. It's q times q times q times another q, which will give me q to the fourth. Now we do it again when we distribute p to the second times q to the third. Okay, so we have that minus in there because there was a minus in the parentheses. And now we're doing p to the second, q to the third, times 2p to the second q. So obviously we have a 2 there. P to the second times p to the second would be p to the fourth. If you want to write out the p's, please do that. And then q to the third times a q would give us q to the fourth. So we're still using those exponent rules. However, we're also using the distributive property. Let's do one more like that because I think it helps to have a second example. So I'm going to distribute negative 3rs to 2r to the second s. So negative 3rs times 2r to the second s. So negative 3 times 2 gives me negative 6. R times r to the second gives me r to the third. And s times s gives me s to the second. Okay, now let's do negative 3rs times 12t. Take a look at what that looks like. Negative 3rs times 12t. Okay, so that's going to give me negative 36 when I multiply the negative 3 times the 12. And then I don't have any of these variables that are the same. So I'm going to have to just write them all out. RST. Okay. One more distributing, negative 3rs. We've got to distribute it to negative 7. So we're now multiplying negative 3rs times negative 7. So negative 3 times 7 gives me 21 RS. Whew, that's a lot. Now, friends, this is something that's going to need practice. Practice makes progress. And so the more you can practice with this idea of when I multiply, I add the exponents. If you need to write them out like I did, please do. I think visually it will help us to see that until that shortcut becomes almost second nature. So let's look at our next exponent rule. Our next exponent rule is raising a power to a power. Now, I want you to think of this like a stamp. So look at the problem I have. 3x in parentheses to the fourth power. What that means is to take that parentheses and stamp it 4 times or write it 4 times and multiply. So you can see I have 1, 2, 3, 4. I've written it out 4 times. Now I can easily see the multiplication. 3 times 3 is 9, times 3 again, 27, times 3 again, 81. And then look, I have x times x times x times x. That's 4 x's being multiplied together, and that's 81x to the fourth. Okay, so you've got to think about how many times do I need to write that parentheses out? So look at number 1 here, m to the third to the fourth. So that means I'm going to write that parentheses 4 times, right? Got to write it down 4 times. We just learned that when you multiply, you can add those exponents. So m to the third would be 6, right? We add another 3 gives me 9, add another 3 gives me 12. So really we're adding these exponents. We're adding the 3 4 times, which would give me m to the 12th. Okay? Think about number 2. I've got to write that out 4 times. So that's 4a to the third, b to the second. Write it again. A third time and a fourth. Okay, and I think particularly this method of writing it out, super beneficial when we have a number in front there, because I want you to see the multiplication. So it's 4 times 4 is 16, times 4 again is 64, times 4 again is 256. Now I want you to add the exponents. So on the A, we're going to add 3 plus 3 is 6, plus 3 again is 9, plus 3 again is 12. And then we do the same thing for the B. B to the second, plus 2 is 4, plus 2 is 6, plus 2 more is 8. All right. Now, let's add a little couple of layers to it. Look at number 3. You've got a 5 in front, but I want you to notice that 5 is not in the parentheses. So you're going to write this parentheses twice because of this exponent, and you're going to have that 5 in front. So we're going to write the parentheses twice. There's once. Do it again. There's twice. Okay, now let's multiply the numbers in front. 5 times 2 is 10, times 2 again is 20. Now you can add your exponents. X to the third plus another 3 gives you x to the sixth. And now you've got y times y, which is y to the second. All right, so see how we added that layer of that number 5 in front? All right, one more example of this rule, and friends, this one is a lot. It's got a lot of layers. I want you to focus on the inside first. I want you to focus in on this parentheses. We're going to write it 3 times. So let me do that. So I've got negative 2x squared times negative 2x squared times negative 2x squared. Okay, there's the 3 times. Now, how many times do we write the bracket? We write the bracket twice. So I've got a bracket that has 3 parentheses in it here. And then I've got another bracket because I got to write it twice, remember, with 3 parentheses in it. Oops. That's a 2 out of the exponent there. Now we can multiply. Okay, negative 2 times negative 2 is 4, times negative 2 is negative 8, times negative 2 is positive 16, times negative 2 is negative 32, times negative 2 is positive 64. Okay, now when you do the exponents, you add them. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10, plus 2 is 12. All right, friends. Now that is the way to keep yourself from getting confused. Just take the time to write them out so you can see the multiplication. It's going to make it a lot simpler for you. All right, you're getting the hang of these exponents rules, but we're not finished yet. We've got more exponent rules to go, so let's take a look. All right, it's time to turn our attention to division. So let's look at the example I have at the top here. I've got x to the second divided by x to the sixth. We've already talked about x to the second really means x times x. So that means that x to the sixth means x times itself 6 times. Now what I want you to see is that you can cancel 1x from the top for 1x on the bottom. So this x goes away if this x goes away. And this x goes away if this x goes away. Now, it may look like there's nothing left on the top, but you need a placeholder there. And the placeholder with division is a 1. And then look at the bottom. I've got 4 x's being multiplied together. That's x to the 4th. Now, this is my answer. Okay, let's do it again. This time with x to the 5th divided by x to the 3rd. So x to the 5th means to multiply the x's by itself 5 times. Okay, now you've got x to the 3rd, which means to multiply x by itself 3 times. All right, remember, you can cancel 1x from the top for 1x on the bottom. So 1, 2, 3, cancel, and you've got x to the second left on the top. I think if you will, notice in the patterns here, what happened? What is the shortcut? Right, so let's write it out. When dividing monomials with like variables, we can subtract the exponents and put the result where the largest exponent is. Okay, let's play that out. I still like to write it out sometimes because it's visually, I can see exactly what's going on. Look at number 1. Start with your numbers in front. -7 and 28, both are divisible by -7. We reduced fractions last week, so that part of it is still the same procedure. So I'm going to divide -7 by 7, which will give me -1, and I will divide 28 by 7, which will give me 4. Okay, now look at your top. You have a to the second, which means a times a. You have b to the third, which means b times b times b. And then you have ABC on the bottom. Now remember, you can cancel 1a for top and bottom. So we'll do that. You can cancel 1b top and bottom. And that's it. You can't cancel anymore. So now we have negative a and b times b, or b to the second. And on the bottom, we have 4 and c left. And that's it. That's as simplified as we can get. Let's do one more like that. Look at number 2. -12 and -20 are both divisible by -4. So -12 divided by -4 is 3. And -20 divided by -4 is 5. Side note, I only divided by the -4 because both of them were negative. All right, look at the top then. I have r to the second, so that's r times an s. On the bottom, I have r times s to the second, or that means times s. Okay, so it looks like I have one r that will cancel top and bottom and one s that will cancel top and bottom. So what I have on top, 3r, and on bottom, 5s. That's it, simplified. All right, friends, let's look at number 3 then. A little tricky because now we go back to our power to a power rule where we've got to rewrite that parentheses, and it looks like I'm going to rewrite it 4 times. So I've got 3s times 3s times 3s times 3s, and then on the bottom, I've got 3, and then I've got s times itself 4 times. So s times s times s times s. All right, so one of my 3's will cancel, and then it looks like my s will cancel. Remember, 1 on the top cancels with 1 on the bottom. Nicely done for us. It looks like we have left over 3 times 3, which is 9, times 3 again, which gives me 27. Now, friends, I think you're going to be successful with this simplifying if you will be disciplined to write out the exponents to the repeated multiplication and then cancel them out top and bottom so you can see that easily happen. All right, one more. This one doesn't have any variables in it at all. These are actually in what we call scientific notation. We're going to talk a little bit more about that here in a minute. But look at the numbers in front, right? 12 divided by 4 gives you 3. Now look at what you have on top. You have 10 to the 6th. So that's 6 tens being multiplied together, right? There's 3 of them, 4, 5, and 6. And then on the bottom, you have 3 of them, 10 to the 3rd. So 10 times 10 times 10. 1 10 on the top cancels with 1 10 on the bottom. 1 10 on the top cancels with 1 on the bottom. There we go. Look at what we have left. We have 3 times 3 tens being multiplied together. That's 10 to the 3rd. I hope this is going to get you started as you want practice through these exponent rules. They are just going to need to have practice with them for them to become routine for you, to feel comfortable with them. I hope I've shown you how to write them out so that it doesn't feel like you have to remember all of these shortcuts. Okay? Embrace the shortcuts if they help you. If they don't, go back to writing out that repeated multiplication and cancel them out top and bottom.